So hello everyone, welcome to the third session of the Students Learning Seminar. Today Srijit Mukherjee of MStat second year from Indian Statistical Institute, Kolkata will be presenting a talk on how to make R learn your own handwriting. So start Bhaiya.
Hello guys, welcome to this session. So this talk really gonna be, it was really interesting when I started doing it. So I was starting to think, so it was like time of COVID, and I was starting to think that how can I make the computer write my handwriting, how to make, I will just give them the sentence, I am Srijit Mukherjee, and the computer will write out in my own handwriting style, okay? And similarly for your own handwriting style. So I thought of that, and therefore in some few days I came up with this. So it's really easy and anyone can do it, okay? It's really easy. The basics is also easy, the theory part is also easy. It's just basic regression, but like in a 2-dimension in stuff, okay? We'll see that bit of math over here. So let's go ahead. What is this? It's really all about. So I will tell you the steps. I will tell you the whole procedure I'm doing. I will tell you the steps that what we exactly gonna do in this whole thing. Then I will give you, okay, then you will see it slowly, okay. The steps. So essentially, suppose this is the idea that to get the computer get accustomed to your own handwriting, you must first give the computer your handwriting, right? So suppose you're writing your name, so you must first give the computer your name, how you write your name, okay? So remember that your name, just suppose you sign your, like, or suppose you write your name on a piece of paper and you like you just give it a computer, okay? It will not really happen in that. Yeah. Okay. Sure. So okay. So consider this, that suppose you give your name to a computer. The computer will not register your handwriting style. Why? Because the computer does, suppose you give you the name the S, okay, or say the D on the top. The computer doesn't know that how you write the D. You just where to start and where to end, okay? So you just also need to like let the computer know how you are writing the D, okay, the sequence of steps. So therefore what you need is that you need the coordinates of each of these points, and approximate coordinates along with the timestamp. So essentially what you need is a sequence of points P in a plane. So with a timestamp, okay, with that stamp, what is the first point, what is the second point? So you're drawing like this. So you need the timestamp. Okay, that is what you need for the data part. Okay, so I hope all of you understood this. So I would like if you just reciprocate yourself in the comments. I mean in the message section. Okay, okay. Okay, what's next? The next part is the algorithm part. Okay, so we have a sequence of points Pn, xn, yn, that is Pn, and we need to estimate a function f, okay, f from 0 to 1 to r square, okay, suppose this curve, okay, through this Pn, okay. So the sequence of steps is being preserved. What does it mean? That f of 0 should be around this point and f of 1 should be around the end point. Okay, this is sort of the time, the time through which you are moving, the function is moving. The problem is that if you consider this, this is not actually a function, okay, it's a mapping in some sense. Why? Because not really mapping. What I mean is that the problem here, what can happen is that, okay, let's see an example, okay, let's not go into here. The problem is that while you do statistics, you don't really have when you do regression, you don't really have that how to make this directly, okay, how to like estimate this directly. So we will take a different way out, okay. That's the only natural way to do it. So after this, what we are going to do is the following, that we will show the animation of how it's being done, okay. So suppose you're drawing the circle from here, so you will see the circle, and there's a beautiful package called GG Animate in R, which you can it can be used to teach a lot of people, okay. I mean, suppose you're doing linear regression and you can teach your students like, yeah, essentially it's being minimized, the sum of squares and minimize. So one person got an award, I forgot, he created actually a package called animation, okay, and he got one of the best package or something paper award for the using GG Animate. He created a lot of educational stuff. So it's a really beautiful, and I mean if you want to play with it, it's a really beautiful one, okay. But the problem is that I cannot really show you the animation because the Adobe Flash Sphere is not being like supported from December 2020. So I will show one of the animation. Okay, just give me a moment. I will show you one of the animation. So essentially, I will show you what I'm really trying to do. Okay. Nice. Let me see. Okay. Just give me a minute. Yeah. So this is what I'm going to show you. See this. So essentially, this is the circle we are going to animate. Okay. So you are giving the data point to the circle, and this is essentially what we are aiming to animate. And we will teach the computer how to do this. So essentially, instead of the circle, this is a very easy example. Instead of the circle, we'll be taking your handwriting method, okay, to how to to show you how to animate this. That's the entire idea over here. Okay, let's move ahead to that. Yeah. So we have this data. We have the anime algorithm. So we will see how to estimate this using statistics, and we will use this animation part. Okay. So let's come to the data. So what is the data? The data, if you see, it's a sequence of xn comma yn, okay, just points. So the thing is that how do you collect the data? That's the main thing, and that was the most challenging aspect in my case. Okay, so Arnab sir has suggested me to do it in Java, but I was like not being able to do it. So I used it via, also given an online site. Okay, so I used it maybe that site to like get the data. Okay, I will show you while doing the example, but I will show you how the data looks like and how it looks like online. So suppose you go to the following site, I will give you the site, everything. So you upload the pictures, say like this, of this song over here, of this like musical note over here, and you draw on it, okay, the way you are drawing it, okay, and therefore you get the sequence of points. So we have got the data of the sequence of points over here, okay. So we uploaded the picture, we draw on it the sequence we want to draw, and therefore we get the data. Okay, that's it. Perfect. So yeah, so that is one of the way to you collect the data. The other way is using other, like maybe Java and Python, you can do it, but I don't know how to do it personally. If you know it, like it will be really useful for me. I mean, I want the following, that I want a like I will write it normally on a whiteboard, say, and automatically I will be given the data, okay, back in the sequence format. So if any one of you know how to do it, please let me know. It will be really helpful for me. Like it will be also enjoyable, it will be much more easier. Okay, so yeah, we have got the data. Now we will see the math behind it. Okay, so essentially
just one question, Srijit, may I ask?
Sure sir, sure.
The question is, are the points temporally equispaced?
Sir, no sir, I will show you like how we collected the data. It's not temporally equispaced.
Okay, so if there is a corner, then are you always including that corner?
Yeah, I am drawing randomly. It's like not, I'm just trying to make a very close data points. Okay, so I will show an example. Okay.
Okay.
Yeah, so then you can like tell you what's really happening over here.
Okay.
Yeah, so we have got the data out here, and so essentially what we will do is that instead of, so regression here, we need to estimate. We can't really use estimate of 101 to r square easily. Okay, so what we will do is that when there is no regression part, because there are like meeting points, that will not allow in the regression framework. So what we will do is instead that we will so essentially it's a two-dimensional like points, right? So it's, observe, if it's every f of t is actually like coordinate of f1t and f2t. Okay, so we will estimate f1t and f2t instead of ft directly. So that will come under regression framework. Okay, and let's see an example. So then we will estimate using the coordinate xn f1t. We will estimate f2 using the coordinates yn. Okay, and we'll use the normal. We will see why we are doing this. Okay, we will see that. Let's say an example. For example, if you take the circle, circle, it's cos x comma sin x. So you can use this. You can get this data from here. You see, it's almost like that. Okay, so it's this is occurring because of that variability, but essentially looks like this. So this is the xn's and yns are happening like this, and yeah, so now we are individually approximating this corresponding xn's and yns. Okay, using various regression like models. Okay, that's the idea over here. Yeah, so for example, I did the LinkedIn logo. So here I mean, it's just moving in the same. So we will see this example like a lot of times. Okay, so now I will discuss a bit of more statistics over here. Then I will move into applications. Okay. So any questions till now, guys? I would love to have your questions now. Any questions from your side now?
Yeah, Srijit, so isn't this a time series?
Yeah, it's sort of a time series. Yeah.
Which
Right.
means we can't use normal regression techniques.
No, this is actually not time series in that sense, but and this is a different. I mean, time series is a different framework, different philosophy behind it. But yeah, the math behind it is essentially that of the time series and essentially of the regression. But the time series means they are interdependent. You are correct, but here there is like a very what should I say, a different structure over here. But yeah, I mean, I didn't get your point. Like, what's your question?
Like if we are going to use normal regression techniques, then our assumptions that y variables are supposed to be independent of each other, that assumption is violated.
Yeah, that's why we will use a very difficult framework of generalized additive model.
Okay.
Yeah, so we'll see why we will use that. Okay, we will give you the motivation. Okay, what model I should use. I mean, just I am asking you that whether the algorithm, the steps we are going to do is clear or not. The math part is the essential statistics part is coming step by step now to you. So any questions till the steps part, like what exactly we are going to do? We have the data part. We then have the corresponding part of the estimation. We are estimating F1T and F2T, and then there is a animation part. Okay, that we are going to do using GG Animate. So I will give you the codes. So there is nothing to teach you here. It's essentially you have to practice it and like learn it yourself. Okay. So yeah, essentially this is a whole step out here. And the main part was the collecting data and this estimating the F12 and F2D. Okay, F1T and F2D. Okay. So essentially, I will tell you why I use generalized additive model, because I remember asking Arnab sir in my stat compre third year that, so I asked him essentially this, that, so I am a fan of cricket. Okay. Oops, everything fine. Hello.
Yeah, it's okay.
Yeah, can you hear me?
Yeah. I think his connection dropped.
Still now?
Hello.
Can you hear me now?
Yeah, you dropped out for a minute. It's fine now.
Okay. Fine. Okay, so essentially, I remember I was telling the story, like what really happened. So I am a fan of cricket, so I was interested in how to predict the score of Virat Kohli. Okay, so in if you see the scores of Virat Kohli, it's also a time series as Anvit has told. So there were like sharp points, okay, bends, like it's like this sharp bends, okay, of the scores of him, because one day he has done 100 and then the next day he has done 0. So how to get the sharp bends? So he told me the generalized additive model really helps over there, and we'll see why it really helps. Okay, now today. So that's why if you see over here in this example, it's sharp bounce, like sharp bend. See, and with since you asked the question. So in these cases, you will see it's really just a simple. You can do just simple regression. But if you see this like handwriting stuff, it will come like it will turn out that it's really not easy to do the normal regression stuff. We need a different framework, as you have told. Okay. Okay, so let's move ahead to the next one. So we will just briefly recapitulate what we know a bit. So we know the basic standard linear model, as we know. That is this format. We are like equating the mu with the in a very linear format with the data xi. Then we have the polynomial regression framework where we are doing mu with as a polynomial. Okay, we are remember that we are expressing an expectation of y given x. Okay, so that's why we are doing the mu. So that's a very important stuff. So y given x, we are sort of seeing as like as a function of the x's. So this is the basic two models that we know. Essentially, this kind of transform into a like this will be x over here, I guess, or maybe it should be x2. Yeah, yeah. So that's it will be x1. Sorry here. Okay, so the next part is the generalized linear model. So where we have this link function g, and we like estimate G of mu is equal to beta naught plus beta 1 x1 plus beta 2 x2. Okay. And yep, so and then we have generalized additive model, which is a general function over here. So we'll see how the functions look like. Okay. So let's see. Yeah. So why we need the generalized additive model? It's also called GAM. So if you imagine the data coming from this distribution, this ugly, not ugly, but okay, mathematically elegant distribution, you see that this epsilon follows normal 0, it's the same framework, but you see it doesn't. We will see that doesn't really follow the framework. You see, it's like locally it looks like stuff. Like if you first you estimate here, then you estimate here, then you estimate here, then you estimate here, then you estimate here. It's locally like polynomial. So you can use local regression using polynomials and stuff. But we'll see how to like do it in a general framework. Okay, we will see that. That's the idea need for like generalized additive model over here. So if you do polynomial regression on the same data set over here, you will see that it doesn't work really good because of the very smoothness of the curve. Okay, we don't really need that smoothness over here. We need local smoothness. Okay, so polynomial regression is not really working over here. Okay, so people are asking me to slow down. Am I going too fast, guys? Can you please tell me why it's going very fast?
Yeah, Srijit, I think we can,
Can you tell me where I went first? Then I can really.
Yeah, you are going fast and you are flipping through the slides very fast. So,
okay,
so hold them for some time on the screen.
Okay, sir.
So that we can read.
Yeah, sure. So which part I think you should like I should repeat, sir? I mean,
no, it's okay. You can proceed from here. Yeah,
okay.
Just remember that in general.
Sure. Thank you, sir. Okay, so so let me see this. Let me recapitulate from the beginning. So the standard linear model that we know is essentially this: like y is equal to beta naught plus beta, like b naught plus b1 x1 plus epsilon. Okay, where epsilon follows normal 0 comma sigma square, and essentially we are estimating the mu in terms of the mean with respect to the data. Okay, linear function of the data. In polynomial regression, we are actually expressing mu, the mean, in terms of a polynomial format of the data. Okay, I mean the x's, I mean dependence is in a polynomial format. So in generalized linear model, we are giving a bit much more freedom by using a link function g of mu is equal to, now we are expressing that so g is essentially required. It's best when g is inverse. So like is a bijective function so that we can take inverse easily now. So g of mu is equal to b naught plus b1 x1 plus b2 x2. Okay, so that's the generalized linear model part. But here we'll see a generalized additive model where it's g of mu is equal to f of x. Okay, so we will see how the f of x looks like now. Okay, so we are giving an example that why we really need generalized additive model over here. Okay, that's the whole point over here to make you understand why we need it really. So if you see it, so let's take a hypothetically example that fx is like the y follows this is plus some error over here which follows normal 0 comma 0.3 whole square. So it gives a function like gives a like thing like this. Okay, output like this. So the idea is that if you see it very carefully, it's not really a good polynomial. It cannot be really estimated by a good polynomial stuff nor by a good linear stuff. I mean linear is a part of polynomial. Rather what is expected is that it should be like sort of, it's first of all continuous and it should be piecewise polynomial. See, first of all you're thinking that maybe there is a good relationship in here, then this part. Okay, I think I should like open the annotation. So you think maybe there's a good relationship for here and then here and then here and then maybe here. Okay, so this is the general idea that we are getting. Okay, so but we will see that how, that's why a direct really good polynomial fit will not be happening over here. Okay, also because of the fact these are not polynomials. Okay, these are approximately polynomials by Taylor series. Okay, so it will not be really happening over here. So we will see what we really can do over here. Okay, okay, so just give me a moment, let me clear this. Okay, So polynomial regression, so observe that it's not really happening good over here, as I have told. It's not really happening anything. It's not giving any really interesting stuff. So these are the degrees of the polynomial, and how see it's a 2 degree, 3 degree, there is 6 degree. So it's not really giving a good format of the data. Okay, only this. So if you increase the 15, it will increase the number of parameters also. Okay, so you will see how we are really doing this. We also want to not go to high parameter stuff. Okay, it will really give you a bad stuff, and statisticians have done a lot of work in this penalized maximum likelihood and penalized loss idea to correct this stuff up. Okay, so we will see. So we will see a piecewise polynomial regression, but the problem with piecewise is that we need to have a connection of, like, it's not being continuous. Okay, it's not really happening over here. It's a very bad continuous function. So it's not really continuous, but it's really giving a good estimate. But the problem with this is that it's very, these are very high variance. Okay, it's very wiggly. It's in the bias variance trade-off wala framework, it will really give a bad MSC. So because of the, like, it has a lot of high variance, and also it's not continuous. Okay, so we don't want like this. We want a continuous and a piecewise stuff. So we will see, this is essentially the generalized additive model is giving. Okay, so therefore we need to study this format up, what's really over there. So I will not go into too much of mathematics, but I will just give you the basic idea with the corresponding mathematical ideas. So essentially GAM looks like the following, that y is equal to fx plus epsilon, but fx is a sort of sum of its additive, so it's sum of functions. Okay, and how the function looks like. So this is the bjx, which is called the basis functions. So it's like building up correspondingly building the corresponding, what should I say, the function up, the additive functions up. Okay, these are the additive functions we are doing, and for each bj there is a parameter omega j, which we are correspondingly going to approximate. These are the parameters. Okay, so these are the total number of parameters, d is the total number of parameters over here. And observe that so how we are going to exactly do that. So the basic thing is done in the following. It's called penalized likelihood, where what we are doing essentially is that we have a likelihood, but it's sort of like AIC and BIC only. So we are introduce a penalty. What is a penalty? What does it mean? It means that, see, we can try to reduce. So if you know this theorem in multiple, so you can, if you know this theorem in multiple linear regression, you can make R square, like the more you increase the parameters, you can easily make it go towards the R square, go towards 1. Okay, so I mean, so essentially the idea is that you can make it really good approximation, but the number of parameters to be estimated is really like coming out to be a hard task. So to make this happen, what they did is that they sort of introduce a penalty for introducing so many parameters. So if you see the loss function, a penalty is done which is proportional to the number of parameters. Okay, so that's the idea. So this is a loss function, the usual OLS loss function, plus a penalty for introducing so many parameters. And you see the knots over here. So see, if you see the regression over here, there are knots. Okay, essentially they're, anyone wants to say something? Okay, so there are knots over here where they're essentially changing their way of movements. Okay, so those are called the knots. So these general additive models also take that framework over here. So if you see, oops, what is happening? So so essentially if you see it, so if there are k knots over here, so essentially the function looks like this, where we are essentially taking the basis functions to be, the basis functions to be polynomials. Okay, and for d is equal to 2, if you take the basis function in polynomials, and if you take b is equal to d is equal to 2, I think you will get the simple linear regression format. Okay, so that's the idea. So 2 parameters you're getting. Okay, so alpha plus beta x, that's the beta naught plus beta 1x. So the knot, with knots it looks like, so why is the knot useful? Because at the knots we introduce a knot so that between the knots it's actually doing polynomial regression, Okay, sort of, which is called spline regression also. So it's doing polynomial regression, and the knots at knots, those will be continuous. Okay, those are the usefulness of the knots. So that's why it's defined like this. If I will not, I don't want to like make it much more mathematically hard as I have promised. So I just like tell you the idea what's really happening over here. So there is a knot estimation part and there is a parameter estimation part, and yeah, so essentially it's a general framework where the basis functions are polynomials taken. Okay, and essentially we are using this only. Okay, where we are estimating this gamma j's by what? By penalized this format, by penalized loss form, and minimizing the penalized loss. Okay, so that we don't go very much large number of parameters. Also we can reduce the like the actual loss. Okay, that's the idea. Okay, so here for L equal to 1, it's actually for L equal to 1 over here. Okay, L by the L means here the, if you see the L, it's x to the power L. So L means here that we are sort of doing local linear stuff. Okay, we are locally approximating by the between the knots by linear functions. And for L equal to 3, that essentially we use normally, we are using cubic stuff. I mean cubic polynomials for L equal to 3. For L equal to 1, it's local linear. Like the basis functions are cubic when L equal to 3. Okay, for L equal to 1, it's linear. So essentially that's the idea happening over here. So now we will just apply on some data, the real stuff we are going to do today. So any questions till this point, guys? Now it's just all about applications. Any questions? Any questions, guys? Okay, so people are really waiting for the application part. Okay, let me go to the application part directly. So let me open some sites. Give me a moment, guys. Number of knots. Number of knots is not a parameter in, but we can give the number of knots. Okay, where we can give the number of knots to the function. But if you also assign the number of knots, I mean not the number of knots, but if you assign the first of all, as Sarah told, its number of knots is not a parameter. I may have told it wrongly. So when the number knots are given, when the knots are given, they are approximate between the knots. When the knots are not given, it's equally taken. The points are equally space taken. Yep. That like the function does like, okay, by the way, I forgot to tell you something that I forgot to tell you something that in the, we will use a package called mgcv where the loss function is done in a very different format. Okay, loss function is done in a very different format. So it's in something called deviance. I will not discuss that, but yeah. Anyway, so let's go back to, sir. I hope it was, I mean maybe I have told it in a wrong manner. Yeah. Okay, I will go to that directly. The link. Just give me a minute. Okay, I will just go to R. Oops, what is happening? Yeah, I think. Yeah, I got it. Okay, perfect. So I will just start sharing it. Can you see it, guys?
Yes.
Okay, so this is the data. Oops. Okay, so Okay, so let's go ahead. So let's see how we can from where we can collect the data. I will just share the screen of that site. So do you have any special suggestion for something else? I will just pick a random. So first we will collect the data. Yeah. So can you see the site, guys?
Yes.
Okay, so I will upload a picture over here now. So the picture I have kept it. Yes. Yeah. So let's upload this picture. OGA. Is it 0? So yeah. So here is a corresponding. Just give me a minute. I should take out my writing stuff. Okay, now let's not take out this. Okay, so here is a like corresponding picture. I'm trying to make. So let's say how I write golpo. Okay, so it means golpo in Bengali. So we will try to estimate here. We will try to get the data of the coordinates. Okay, like this. So if you just click on this. So Arnab sir, if you have any questions, so from here you can ask me now that how I am collecting the corresponding data.
So will you be clicking on the points separately or just
So
moving your mouse?
I'm just clicking on I am moving and clicking correspondingly. If you have a pen tablet where from which you can write, I think it will help one person to get the points actually. But that's the thing that I cannot write it, and that's what I was telling to the audience, that if any one of you know how to, if I just write it and I get the coordinates, it will be really helpful for me. I mean, if I only move, I will not get the data from here. I have to just click it. It's a bit of hard work, but I have no other way. I don't have the technical like knowledge of till now to get the data.
Now, also when you do it by hand, in that case, you are looking for the cusps and the interesting point. So you are helping your algorithm with your brain.
I didn't get you, sir.
Because when you are clicking, in that case, you know which are the interesting points, for example, the crossover points, etc. But when you are doing with your just a mouse or a graphics pen, in that case, even finding those points will be challenging.
Oh, I see. Oh, I see. Okay, but my idea was that, yeah, you're right. My idea was that, I mean, if we take a graphic or like a algo, like we collect the data. So I think, I mean, the cast and those points are really around, like it will be a very small point. So I think we will get the data of that cast, the period around the cast, if it's really like. But you're right that my brain is unknowingly using that, taking those interesting points. But I can also approximate it very elegantly, right, sir? Here.
Yeah, let's see how it goes.
Yeah,
This
sure.
is interesting. This is fine.
Yeah. So so here, so one thing I will tell you is that, like, we must see that how this data is calculated. So essentially you will get, so I will show you how it's calculated. Okay, it's 0, 0, and here it's x and here is y. Okay, so essentially when you're doing that, you need y to be upward. Okay, here y is downward. So we will see this how we will see the diagram what is really happening. Okay, so here we will upload all the coordinates, finalize. For finalizing this, I will just copy this into the data I have. So I have done it in a text file named data in R in my desktop. Okay. So now I will open the R now. Where did R go? Yeah. Can you see all R? Anvit?
Yes.
Okay. Okay, perfect. So I have set a directory. So these libraries need to be loaded. So this MGCV is the library containing the GAM a function, and MGCV is an algorithm to like calculate. This is a sort of a loss function based on deviance. Okay, so which is minimized. Okay, so first I will read the data. Okay, so I think I should close this here. Okay, so now if you see the data, if you plot the data rather, so it looks like this. Okay, if you plot the data now, I have not given it. Oops. If you plot the data, I see Golpo is being reflected. Okay. If you see the, if you zoom in, can you see the picture? Can you see the picture?
Yes, sir.
So Golpo is reflected. So essentially the data is colored in a different manner. Okay. So what I need to do is that I need to just first I will name the column name. I change the column name and see if you see what really happened now. So X and Y is introduced. And I will just change the data to this. Okay, now let's plot. Oops, what happened? Oh, I see. The data name is changed now. The column. Okay, see, also you can see the data now. Here is the data. Oh, hey, it's open, I guess. Here is the data now. Okay, so the GAM will correspondingly approximate through this. Okay. Okay, lovely. So now we have plotted this, and this is how the data looks like. So what we need to do is now you need to create the timestamps. Okay, the time that is going through it, because it's important for the animation part. Okay, so that is a sequence. This is a sequence part. This is a time part. Okay, the sequence part that we have done over here is the time part. I should make a comment. Yeah. So I will now create the data where the data is a time frame, the x coordinates and the y coordinates. Okay. So if you just see the data now, so it's a sequence is a time coordinate. These are data point x, data point y. Okay, that's the data now. So let's plot. So if you see the plot, it's essentially this plot now. Okay. Okay. So now first we'll do the we'll do the regression model on the x coordinates. Okay. First the x coordinates we will do. So what we'll do, we will therefore from the data I'm taking out the x coordinates, by this columns, two columns, the sequence columns and the x columns. Okay, the x coordinates. So this is what I'm doing. This is the x coordinates I'm taking out. Let's plot x. You will see how it looks like. Essentially, see, it looks like this. See, x looks like this now. So we are going to estimate this by spline, by the GAM. Okay. Not so, and you see the bends over here. So that's what Sir was talking about. This is the bends, how they are really calculating. So this bend will not be really calculated. It will be approximated by a smooth curve. We'll see that. Okay. So now we are fitting the additive model over here, like x fit. Okay. So let me share what is really happening. So the data dot x. Okay. The sequence is the time. Essentially, S means I think smooth, and K is the number of knots I'm giving. Okay. So I will do it with a smaller number of knots. Okay. We'll see the difference. Let's do it with 10. Okay. So that's why a larger number of knots I have used. Okay. It will give you, if you do 10, you will see how it looks like. Okay. So let's do it for 10 and let's predict it. Okay. I already predicted. Now let's plot this together. So we'll see how it looks like. Okay. You see now how it looks like. I should add a color to it, I guess. Okay, so observe this. So observe it's not a really good plot because of knots are not being realized over here. So we need to get closure knots. Okay, that's why I've increased the number of knots to 150. Okay, so that's what sir was asking, that the knots, number of knots was really important. So that's what I'm doing, that I will now make it 150 now, number of knots. So if I do the 150 knots now, let's predict it. So this is a prediction function, okay? It's like really hard. So let's see the plot now. Yeah, see now, therefore it's a really beautiful plot now. Okay, so this is the way we are going to use the, so essentially it's locally it's doing like this. See, so the knots are, number of knots increasing is the most important step out here. Yeah, so yeah, that's it. It's can't really done without the knot structure.
Hello.
Yeah.
So how many data points did you collect?
I collected
about 200, right?
Yeah, I collected a lot of data points. No, not a lot. I mean, yeah, we have collected.
You are using 150 many knots, so isn't it too much?
It's also, yeah, it's too much. But it's just for fun I did. So yeah, it's too much also. Yeah.
Okay.
Yeah, but yeah, you're right. It's too much. So we can see like how much we can reduce it. So let's try it out. 50, say, let's say 50 works or not. Let's see 50 works or not. But you're right. You're totally right.
Yeah, it is too much fun, actually.
Yeah, you're right.
Yeah, I guess even for 50, it will give such a nice fit.
Yeah, actually, yeah, yeah, you're right, actually. What is happening over here? Did it crash or something like that? I don't know. Oops. What is happening? Oh, why came out here? Okay, let's try to do it 50 over here. Yeah, 50 is also giving good result. Yeah, actually, thanks for mentioning this, actually. Let's try to do it again. Okay, fine. What is really happening? Just give me a moment. Yes. Yeah. So 50 is giving a good estimate too. We can reduce it down. Okay. So essentially, yeah, you're right. So we can reduce it down a lot of numbers. A smaller number. I think it can 20 and 25 worked out for me. Okay. So yeah, that's the idea. Thank you so much for mentioning this point though. What was your name? Like who? Actually, I didn't get you. Who you were?
Oh, I am Aditya.
Okay, hi, yeah, Aditya. Okay, so yeah, thank you for mentioning this. So let's do it for Y now. Maybe you can.
And are you fitting this differently for X and Y?
Yeah, that's what I told in the initial part. Because because the regression framework will not fit into that F from 0, 1 dimension, 2 dimensions. Okay, so we need to do it by single dimension from 0, 1 to x-axis, 0, 1 to y-axis, and then we will. Because I mean, if F is continuous,
I think you will merge them together using the timestamp. Is it?
Yeah,
so?
yeah, right. Yeah.
Okay.
So now let's do it for Y. But yeah, we can like really do this in 25, let's say. Okay. Oh, we didn't fit Y. Let's see Y. How does it Y look like? Y look like. Why is my R working so slow? Okay, so let's see what is really happening. R is not responding.
You have to change the above 50 also to 25, I think.
Yeah, that will be not a problem. But my R is not working. That's sad. Yeah. So just a minute. Okay, so we have this r over y over here. Okay, the y coordinates over here. I hope you can see that. Just
Yeah, we can see them.
you can see, but I cannot.
Yeah.
Okay, great. So yeah, I think I should add the color. Yep. So let's fit. Okay, we have fitted it, and let's see. Let's plot it. What is happening? God. Okay, I'm sorry for this. I don't know like what's really happening to my R. Yeah. So we have got this over here. So you see a bit of changes over here. This is not being captured. That's why maybe let's see, try to increase the, I don't know, maybe increase it to 50. I don't know. And actually what really happened in my case was I saw that it was not really working for a small number. So I gave a big number just right away. Okay. So I saw it was really working good. Yeah. So it's working better now. See? So yeah. So the number you use, the more you use, more it's better. But yeah, that's it. Yeah. Okay. Perfect. Okay, so we have got this part. Now it's time for this animation part. So you can learn this animation and it's really useful. This is the plot I have got. There's a problem over here, you see. This is bit of problem over here, but I think one can. Okay, yeah, there's a bit of problem over here, but yeah, essentially I hope you understand now how we fitted it both together to get the whole output out here. Okay. So yeah, but it looks much more natural this time. Okay, so let's try to animate it. So let's directly do the animation so that you get. So I will not teach you what is animation. It's essentially what is animation. GG animation is doing. It's like creating ggplots over ggplots over ggplots, lot of ggplots, and merging them together like a film. Just like you remember. So just like we do the like, it's just the normal way it's done. Okay. So essentially, it's building up with ggplots. Okay. And this person who have done it, he is a really, so there's something called something I forgot the name, some machine art or something like that. They create algorithms which create art. I forgot the name. So he has a website where he has done a lot of such work. It's really beautiful. The art is really beautiful. Okay, so he has used GG Animate to create a lot of art, and he is now selling it to he's like living on that. He's also working in our studio. So okay, I forgot the name of that person. You can just get it from his GitHub profile. Okay, so let's see the animation over here. What really happens? You can see the animation over here after some time. My art is working so slow, man. Let's see when we get this output.
So while art is working, let me ask a simple question.
Sure, sir.
What is the total number of parameters in your final model using the number of knots, say 150?
So a lot of parameters. Let me think. So if there are so knots, I mean, oh, acha, I see your point.
So between two knots, you are fitting a curve that has its coefficients.
Mm-hmm. Yeah. So just let me go back to that equation.
No, just a rough idea. Just a rough idea.
It's proportional to. So no, see, that's a rough idea. I don't think it's okay. I mean, these actually, these determined by the minimizing the loss function also, right? Because it contains t.
Right. So that determines the exact values that you are choosing. But I am talking about the number of such coefficients. So if for each segment, spline segment, you have something like, say, on an average 3.
3, yeah.
coefficients. In that case, 150 pieces.
Yeah, 150 parameters.
3, that will give you 450, but you had only 200 points. So my point is, if you just keep on joining all the successive points using your animation, so that is also a
That would
content.
also, yes.
That's also true.
So how will that perform? I have no idea. So will it perform better
So
or
the
what?
idea is that then there is no statistics over there. The statistics is involved. I mean, there is no error part over there then, right? So the statistics is involved because of this to make it smoother, just like our handwriting.
Okay. So the extra advantage is that you are making it smoother.
Yeah.
Okay.
So I have tried it. What you have told, it's becoming like it's coming out like I mean, it's coming out. The small perturbations are coming up. So the GAM is helping us to make it smoother, just like we draw.
Okay. Okay.
Yeah.
So here is one example where reducing the number of parameters is not the goal, but smoothness is the main goal. Okay.
Yeah.
Okay.
Okay. I have another question. While I mean creating the data, you were just clicking by mouse, right? So, and you went in a way so that basically you don't have, you can write it without lifting your pen.
Exactly. It should be continuous. Okay. It should be continuous.
Right. So if we want to produce something that cannot be done in that way, then
so you want discontinuous stuff?
Yes.
So you want to do discontinuous stuff?
Yes. So there we would have a problem, right?
No. So there what I have done is that if you saw that LinkedIn wala stuff, so let's see some animation is coming.
Oh, okay.
So this is what we are having by animation. Okay. So yeah, you can write anything over here like this. But yeah, regarding your point, what's really happening is that the continuous stuff, what I have done is that in that case, there needs to be a little bit of work done. So essentially, suppose you want to write, so you want to take the whole picture. So it's such a big work. Okay. Suppose you want to write a whole paragraph over there. Okay. So there should be, you should, suppose you want to write all the letters. Okay. A, B, C, D, just side by side. Okay. So what you need to do is you first need to store all the data of A, B, C, D, and till Z, say. Suppose you want to write A, B, C. So you get the data of A, you get the data of B, you get the data of C. Then you have to look at and shift it. Okay. So you start the A with this portion. So then you have to shift whatever the B value is,
so
you have to shift it to right. Yeah. So you need to change the data. And then for the animation part, we need to use it. The timestamp should be like A first, and then you should write B. So the timestamp should be like that. So that's for that.
We have to tell the program that it has to stop there and it has to start from a different place.
I mean, you have to, exactly. Yeah, that's
okay.
Right, So this is like a small, so it's not really, I don't know how much useful it is, but I really enjoyed doing it. So I sort of thought of sharing it to you. Yep. So any questions from you guys?
I had a doubt. Can the same code be run in Google Colab? Since, right, it should work, I guess, right?
Yeah, it should work.
Okay.
I will share the codes with you, okay?
Okay.
Yeah. Any other questions?
So Srijit, I have a question. So is it more like you have some picture or figure and you are tracing the outline of that figure and then making the R or your computer retrace it? Is it the goal? Because I mean, in handwriting can be a bit more complex than this. I think Aditya was right in pointing out that you will take your pen off the paper and bring it back.
Exactly. So I have tried using that. So I have written my handwriting. So I will show you how handwriting looks like. So I have written handwriting, but it's a continuous stuff. Okay. So continuous things can be done.
Because like, I mean, paw, you don't write paw or law like that. I mean, my son does that, but he's not supposed to. So it becomes like that. So you take your pen off the paper and then bring it back, things like that.
Essentially, you have to teach exactly how you teach your son, like you have to write Paul like, so essentially
so it's hard for him to still get it, but generally when we write Paul, we take our pen off the paper several times.
Yeah. So you have to tell the computer, okay, it's time
Yeah.
for you to leave the paper, off your paper,
Yeah.
and like change it. So
So
actually,
you take your origin to someplace else and restart again.
Exactly. But that's a lot of work. I don't think. I mean, I don't think it has so many use. I don't know if you have anything on your mind.
And then another point. So like, I mean, possibly you can teach the computer write all the basic alphabets or basic symbols in your language, whatever it is. English will have fewer, Bengali or Hindi will have a lot more. But then, I mean, when you in a handwriting, when you write two alphabets one next to each other, depending on how you are pairing them, your handwriting keeps changing, isn't it?
Exactly, sir. You're right.
So that should make it even more complex.
Yeah. So I have tried this one out with my own signature.
Mm-hmm.
So this worked fine. But yeah, what you told is totally correct. That continuous things is discontinuous stuff is a bit hard, but you have to tell the like where to start and how to start. You have to just tell it, just like we tell our mind.
That's one thing. And the second thing that I tried to say, like, I mean, most languages, except possibly for Chinese and Japanese,
Chinese. I tried Chinese.
The most languages have basic building blocks, and you try to build up a language from those, like the alphabets. From that, so you teach the alphabets and then let things run. But then the problem is when you juxtapose two alphabets next to each other, and then depending on who, so write A next to B or A next to C may look different. That happens. I mean,
yeah. So maybe
you write them differently. I mean, when we do it differently, don't we?
Yeah, exactly. We do it differently, but I don't think computer is too much like.
Yeah, I mean, I'm just discussing what are the
you're
things
totally right. Yeah, totally.
Dream about. I'm not saying like these are necessarily immediately feasible. I'm just, like, it's dreaming.
Yeah, but I didn't do any further. I don't know what is the use of it, but I really enjoyed doing this.
No, it's a nice attempt. I appreciate, but I was just trying to discuss what are the dream things can be.
Yeah, I thought of making an app also.
Like, have more ideas.
Yeah. So I thought of making this like Krishanu sir will give us his handwriting, and we will sort of she will write like, I will go to teach you. I'm going to take a surprise test tomorrow, and that will come up in his own handwriting. Say, so that was my aim. So, but I think it's too hard for me to now, given the same exams are coming. But yeah, it's really enjoyable to have this one.
Yeah. Okay.
Thank you, sir. Yeah. Any other questions, guys? Okay. So yeah. So I have almost taken 1 hour. I hope you enjoyed it, and I will share the R codes with you and the PPT with you. So see you next time, and don't forget to like get added to the mailing list of the student ISI seminar. So Adrita, can you just give, or Anvit, can you give the link of our Google site in the message so that we can get added to the mailing list?
Yeah, I'll do that.
Sure. Okay. So any other questions, guys? Or
I have one suggestion that you may look at.
Sure.
There is a software called Inkscape. I don't know whether you've heard about it. Inkscape.
Okay, sir.
Inkscape, and that software allows you to draw just a freehand line, and it will parameterize it in terms of splines, etc. And there you can set the knots. So there is something called the smoothness parameter, which you can move from something like 1 to 100. So higher the number, more, in that case, more knots it uses. And it just does it online. So you can just, not in online, but in real time, I wanted to say. So you can just try it with that. So that also has the same thing. It's open source thing. So you might try that.
Yeah. Sure. Can you give the link? Okay, I will search. Inkspace, right?
Inkscape. Inkscape like landscape. Ink like pen and ink, and scape.
Inkscape. Okay. Interesting.
Yeah.
Acha. Oh, I see.
And I can send you a Java code which will do what you wanted. That is, if you move the pen, it will give you a list of all the pixels with their timestamps. I can send that to you. Yeah.
Sure, it will be really helpful, sir.
So that you can try. Yeah.
Sure, sir. Okay. Anything you want to say, Adrita and Anvit?
So the time span, I mean, the timestamp is the main important thing here, right? I mean, if we just have the coordinates and don't have the timestamp, then it would have been a much harder problem. Is it so?
Yeah. So without a timestamp, this problem doesn't make sense. Like, I mean, the timestamps are really important. Like, it is the most important part out here. Yeah.
Yes, I mean, making the computer learn how to write it in a handwriting
the
fashion.
computer. You have to tell the computer how you write, then the computer will learn that, okay, this is how I think it's Aditya,
so
right? How
like
Aditya writes.
Completely untractable kind of thing
Yeah,
without the timestamp.
I mean, if you just give the picture, the computer will just, go to sleep. So you have to just give the time points. You're right. Okay. So yeah. So thank you guys for attending, and it was really nice sharing what I love to do. Yeah, that's it.
So thank you, Srijit, for the lovely talk. I hope all of you can digitally sign your documents now.
Yeah.
Join us again next week for a talk on algebraic geometry by Supravada from ISI Bangalore.
Lovely.
Thank you.
Yeah. Thank you, guys. See you soon. Bye.
Thank you, everybody.